We have almost 400 mills in Brazil, and some of them, almost half of them, are exclusively for ethanol production. Okay, and more recently, because the energy crisis, ethanol crisis in Brazil, we have a crisis nowadays there. The mills there are in a very bad shape. We have almost 60 mills being closed because the market is down for ethanol. And this is mainly because the United States entered to the market, and about 3 or 4 years ago, the United States is remaining the exports of ethanol in the world. Okay? And some of these mills, they start to burn the bagasse, that is the remaining part of the sugar cane after the sugar cane comes from the field and is crushed. Okay? And as Mark said, it's about 20%, this means 20% of the electrical power in São Paulo state nowadays. So there is another use for bagasse, not only for bioethanol production, but also for electricity. Okay? And from the side of the vehicles, to use ethanol as a fuel, you have here, I need to find the pointer. Somewhere. Anyway. Okay, very gentle. So if you see, these are the engines, the vehicles being produced in Brazil, and very recently we have electric vehicles being sold in Brazil, and the ethanol vehicles that started many years ago, they are zero. Okay, we have 0 vehicles being produced now, and we have the flex vehicles that can use the. It's not coming. Anyway, do you mind if I use this? And I prefer to stay there. I'm Italian, I need to walk and gesticulate. Okay, so we have this, that's in a red box here, and nowadays if you use this number and divide 365 days a year, you have almost 9,000 vehicles being sold in Brazil or put in the streets every day. Okay? Of course, that all the vehicles, they are removed from the streets. But what is important is that we have the flex fuel vehicles now that they domain the total of the vehicles being registered in Brazil. Most of this gas line here, this comes from trucks. Okay? And if you make the calculation for 2014, we have almost 1,000 vehicles that will be electrical vehicles that will be sold in the market at the end of the year, by the end of the year. Okay, so this means that it's important for us to produce bioethanol or ethanol to run these cars here. Okay, but also the concerns about bioethanol is environmental, and then this figure just shows that if you substitute gasoline, okay, to run vehicles by cellulose ethanol, then you have 86% of reduction of the greenhouse gas that are emitted in the atmosphere. So we will have this greenhouse effect, then this will help to decrease the greenhouse effect. So we have economy, okay, and at the same time we have the environmental. Okay, Marcus showed a little bit about this processing, and I just want to call attention here that you can burn the bagasse that's obtained after the sugarcane is pressed. Okay? And sugarcane also the pressing produce juice that has to be clarified, filtrated, and then you can evaporate and go to sugar. Okay? So some mills in Brazil, they can produce sugar and skip the crisis a little bit, and others that cannot do that goes to production of bioethanol or ethanol. Okay? And if we could use the bagasse as a source of sugars, then we can use these sugars for fermentation and then produce the bioethanol. Okay? Some Brazilian facts about bioethanol, or about sugarcane in bioethanol. And there is a huge market for burning the bagasse to produce electricity. And as I told you, some mills, they are skipping the price, using this to sell the electricity in the open market in Brazil. Okay? And we have about half of the sugarcane used to produce ethanol, and other half to produce sugar. Okay? And with the technology we have right now to produce bioethanol from the cellulose using acid hydrolysis, okay? We can produce 150,000 liters, okay? And if we improve this technology a little bit, it can reach 400,000. So there is a very huge market to increase and to produce more bioethanol from the bagasse. Okay, so this comes to a part, and I told you that I have started working with sugarcane 6 years ago. And at that time, I was thinking to reduce lignin in sugarcane. Okay, but during these 6 years, I changed a little bit, radically, I would say, my thought. I think that lignin is great. Okay, I think that lignin might be used for any other purpose, and also to produce electricity as alternative for bioethanol. And I changed this idea because I'm thinking economically. And most of you have been working in the academy, and when we are in the academy, we just think about science, and we forget a little bit the market. And the market is very rapid and quick to find new solutions. Okay, and burn bagasse is one of them, and lignin becomes so very important in this case. So this is a engineering graphic, okay, and it just says that when it burns, I can burn the bagasse, okay, or biomass, and then cellulose is burnt at this range of temperature, cellulose at this range, and lignin above 500 degrees. So it means that the linkage in the lignin molecule, they are very energetic. Okay, they are very energetic. So if we compare the amount of calories we have in 1 kilogram of dry bagasse, that's here, it's about 4,400. Then we can compare with wood. It's higher than wood, okay, and it's higher or at the same level of some material that are rich in oil, okay, and oil has a lot of energy, okay, and so bagasse means bagasse is a very good source of energy, okay, so burning bagasse is good. So what is lignin? Lignin is a polymer basically formed by 3 compounds, okay? Synapyl alcohol, coniferyl alcohol, and fumaryl alcohol. All this comes from a pathway that we call shipmate pathway, and it starts with phenylalanine, and then several enzymes works here, and one branch goes for fumaryl alcohol, another branch goes to coniferyl and synapyl alcohol. And these alcohols, which are also called the monomers, they are exported out of the cell, and there, by the action, oops, it's missing some words here, you know what's happening. By some enzymes here, lactase and peroxidase, they are oxidized, then activated, is missing, I don't know. Well, anyway, so they are activated by oxidation, and they polymerize and form the lignin. Okay, it's missing one part of the slide here. And so lignin distributes inside of the cell wall, in between the fibers of the cellulose, and makes the cell wall very. We have drought, we have a different alteration, gene expression, despite we don't have a significant change in the lignin content. Okay? But we have change in the profile of the lignin components. Then we have another experiment where the plants were exposed to low temperatures, cold and controlled the normal temperature. And here again we have the diameter of the stem, and as you can see there is a decrease in the diameter of the stem in the internode if you go from the internode 1 to 15. Okay? So the treatment was effective in terms of affecting the growth of the plant. And we didn't have again a significant change in the lignin content. I forgot to say that these plants were grown in these conditions for 60 days. Okay, it's not the whole peak, it's not the whole cycle. 60 days. And we didn't see significant changes in the lignin control here. But again, we saw changes in the profile of the oligomers that were found in these two varieties. And again, the expression was changed if you compare the control and the cold treatment. Okay, so we had some variation here. Okay, so where we are now, a little bit lost, but anyway, we had the idea of the project was this, to find real changes caused by the environment and find in this change good candidates that I could work with. Okay, so we didn't have a very good result if you consider the field experiment or the treatment with low temperature or with the treatment with cold. Okay, but we had a good experiment, a good result if you consider the tissue we analyzed, so the hinge and the pith. Okay, so the parenchymal cells that are the most important cells in sugarcane because they contain the sugar. Okay, they have a differential accumulation of lignin. So if I can change this in the pith, in the hinge, so I will have a lignin with much less G units. Okay, and with the same amount of lignin, and that I can still use for burning or for bioethanol production. Okay, so that's the idea. The point is, how this happens, I don't know. So we have to go for a little bit more to find what gene is controlling the whole process. Okay, and then we have to go for transcription factors. We have some people working now, but not in sugarcane. We found that would be interesting first to get some experience in eucalyptus. Then we're going for microRNA, for kinase, and see what might be controlling these genes here. But as a general conclusions, we think that it's good, lignin is good. We can burn sugarcane, okay? And if we produce a plant that's changed by the expression of the F5H and change the rate of S and G lignin, then we can use the sugarcane for both purposes. And there is a problem that we can have the effect of the environment. So it doesn't mean that what I will get producing this transgenic sugarcane will behave as I expect in the field, when I put in the field. Okay? And also we are focusing now on these three genes here. Okay? Then we are overexpressing Shine and F5H, and Michael is starting to work with this as candidates to produce sugarcane, transgenic sugarcane. That's it.